In this video, we will prove the side-splitting theorem. So what is the side-splitting theorem? This is when you have a line parallel to one side of the triangle, and it tells you that it's going to divide the other two sides proportionally. We often call this side-splitter theorem. So in this diagram, we are given that DE is parallel with BC. If we have parallel lines, we could look at a transversal, AB, to then give us pairs of corresponding angles congruent, such as angle ADE congruent to angle ABC. We also know that angle DAE is congruent to angle BAC because that's the same angle, and so by reflexive property, they're congruent to each other. At this point, if I draw the two triangles separate so that they're corresponding, I can see that I have two pairs of corresponding angles congruent, and so therefore by angle-angle, triangle DAE is similar to triangle BAC. Because the triangles are similar, we now know that their sides are in an equal ratio and therefore proportional. So for instance, side AD over side AB, since those are corresponding, could equal side AE over side AC. Let's now continue this on the next slide. We also want to keep in mind that side AB is made up of segments AD and segments DB. And similar, segment AC is made up of segment AE and EC. If we substitute these two expressions into our proportion, we get the following. Now, we just need to solve this proportion. We're going to begin by cross-multiplying. Once we've cross-multiplied, the next step, of course, would be to distribute AD to both AE and EC, and AE to AD and DB. This would give us the following equation. If I now look at these equations, I notice that I have the same expression, ADAE, on both sides of my equal sign. Therefore, by just using simple addition, subtraction, inverse rules, I can cancel those out by subtracting it on each side. At this point, if I go ahead and make this back into a proportion, I could, for instance, divide each side by dB. I could also at the same time divide each side by EC. This would give me AD over DB equal to AE over EC. If we compare that with our original diagram, we've proven that the top part of the triangle and the bottom part of that side would be equal to the other top part of the triangle over the other bottom part of that side. We have now proven the side-splitting theorem. Again, some key things to remember. In order for you to use this theorem, you have to be first given parallel lines. If you do not have parallel lines, where one is the side of a triangle and the other is splitting the other two sides, you cannot use this theorem. Second, it's very important to remember side-splitter theorem splits the other two sides. you cannot use in this proportion the parallel sides.